Hey everyone, my name is Sheldon Lo-A-Njoe, as mentioned. I'm a staff solution architect at Spectro Cloud, and I'm here with
Nicolas Ferrao. I'm a cloud and edge architect in defense and space. I build Kubernetes systems that don't always have connectivity, don't always have central supervision access, and don't always have second chances. I assume most of you took a plane to come here today, and you probably felt safe, right? That's because you know there are many controls in place before an aircraft ever leaves the ground. When aircraft manufacturers receive a component from a supplier, they don't simply trust it. Every part comes with documentation showing where it was built, how it was tested, and who approved it, as you can see here. Without that traceability, the part cannot be installed. Aviation solved the trust problem with traceability and certification. In cybersec, we use a very similar idea. What about software artifacts? It has been some time now that concerns are being raised about enforcing the supply chain. That's where SLSA comes in, and even more recent news about GitHub Actions problems again. Wait, SLSA, is it the dance? Is it the herbs? Is it the sauce? Unfortunately, in our world, it's none of those. It's supply chain levels for software artifacts. And if you simply run Kubernetes, it's something you absolutely cannot afford to get wrong. When people hear SLSA, it can sound complex, but actually it's very simple. It's just a way to describe the software supply chain, from source to build to distribution and usage. And importantly, including dependencies, SLSA focuses on three things: build integrity. Can we trust how it was built? Provenance. Do we know where it comes from? Traceability. We can follow it end to end. And it gives us a way to talk about security with a common language and evaluate what we actually run. SLSA is not a tool, it's a way to make trust visible. And once you see that, you start to see where things break. Once we map the software supply chain, we realize something important. Trust is not a single point. It exists everywhere in the pipeline, from source to build, to distribution, to usage. And at each step, there are ways to compromise it. In fact, SLSA identifies 8 different places where trust can be exploited. You can inject code, compromise the build, replace artifacts, or even use a valid but malicious dependency. So the question is not, is my system secure? Because everyone knows how to harden a Kubernetes nowadays. Which part of my supply chain am I trusting? Without verification, and that's exactly what we are going to explore now. Let me show you something that already happened. A widely used package used by thousands of applications was compromised, not by hacking it, not by exploiting it, but by gaining trust. The attacker became a maintainer, added a new dependency. The code worked. It passed reviews. It passed CI. It got deployed everywhere. On the second case, this is exactly what happened in SolarWinds. You all heard about SolarWinds, right? Attackers didn't touch the code. They compromised the build pipeline. The pipeline injected malicious code during compilation, then produced a perfectly valid artifact. Signed, distributed, trusted. The source was clean, but the artifact was not. The third one, nothing is hacked. Nothing is broken. Someone simply pushed a new image using the same tag. Kubernetes pulls it automatically. Same tag, different content, no alert, no visibility. Tags lie, directions don't. And I'm not speaking about tag latest, right? This case, GitOps is powerful. It ensures what's in Git, what runs in production. But what if Git is wrong? A simple change, a modified image reference, and the system deploys it everywhere, automatically. A nightmare. No breach, no exploit, just trust. Automation without verification is amplification. This one is subtle. The artifact is real, the signature is valid, but it's old. Maybe it contains a vulnerability that didn't exist at the time, or wasn't known yet. The system accepts it, because it's valid, but valid does not mean safe. So, if we step back for a second, none of these attacks required breaking Kubernetes. Kubernetes worked exactly as expected. CI worked, the registry worked, GitOps worked. What attackers exploited was not a vulnerability. They exploited implicit trust. The system assumed the build was correct. The artifact is authentic. The update is authorized. And those assumptions were never verified. That's the common pattern. Not broken systems, unverified trust. And at some point, the system realized, I trusted you. This is exactly what happened in SolarWinds, in event stream, in every example we saw. So we say, what stops these attacks is verifiable evidence. Now, let's make things worse. Because everything we just discussed becomes significantly harder at the edge. Not because you have one data center, but you have thousands of them. At the edge, you don't have continuous monitoring. You can't rely on a SOC, watching everything in real time. You don't have an always reachable authority, no constant connection to verify signatures, identities, or policies. Detection is delayed. You might discover an issue hours, days, or weeks later, or never. There is no instant rollback. You can just redeploy instantly across disconnected environments. Physical access is possible. Devices are in the field, not in a data center. And failures propagate slowly, but widely, which makes them harder to detect and harder to contain. So, at the edge, you cannot rely on reaction. You must rely on prevention and verification. And that changed the model completely. So, if we can't rely on monitoring, if we can't rely on connectivity, what does trust look like? Trust must be embedded directly into the artifact. First, the build must be reproducible. Meaning, given the same inputs, you always get the same output. No hidden behavior. And that's come from infrastructure as code, right? Then, every artifact must be signed, so we can verify who produced it, and that it hasn't been modified. But signature alone are not enough, because keys can be stolen. GitHub Actions? Anyone? So we anchor trust in hardware, where keys cannot be extracted and require physical presence. And finally, verification must be automatic at deployment time. No human in the loop, no optional checks. If it cannot be verified, it does not run. I hand over to Sheldon now.
Okay, so this of course has all been very theoretical. I will try to show you not a live demo. This is, of course, I don't want to anger any demo god, so there is a recording. Yeah, so you'll have an application, you'll have infrastructure, you'll have to deploy it. I'll go through the whole process, and I'll stop it as we go. In this case, we have a platform, which is our Kubernetes management platform palette. Here we have an edge device. This, of course, can be, the important thing here is cloud, is edge, but this can be in the cloud or bare metal or any other infrastructure. In this case, this is a Latte Panda, which is an x86, a small form factor device. The device itself is running a specific stack. The stack itself is fairly simple. It has an operating system, Kubernetes or K3s as a Kubernetes flavor, Cilium as networking, and then we have Argo CD and Governo. In this case, Argo CD will be what does the actual automated deployment of your resources. So you'll push everything to Git as you would want to as a developer or code deployer. And then it automatically pulls onto your infrastructure. Governo is what we'll be using to actually validate the resources, because if you just deploy everything in your cluster and you get, somewhere within that process, something something wrong happens, right? Some vulnerability is applied. You will then have a problem because it then automatically deploys and it might scale to whatever infrastructure you have. So in this case, Governo, Argo CD, and the configuration itself is actually fairly simple. So for, let's say, Argo CD, of course, you'll have an application. This will be, in this case, I have a GitLab repository that I'm pulling from, and just from the main branch. And in Governo, two very simple policies. So a required signed images. So it only allows images from a certain repository and registry. And it has, where you can see there at the bottom, there's publicly also attached. So you'll be signing the images, and the configuration will contain the public image, then validate that as well. And then the SLA provenance verification. So you'll have it will require for the provenance to be applied and that attestation to be available. So very simple, just two resources or two CRDs for Governo and then your application for Argo CD. The application itself, so it's fairly dark, it doesn't really matter. This vibe-coded application is just a sample app for how you go through the process for SLSA, right? So you build your application, you sign it, you attest it, and then it's verified and deployed. This application has a very simple version. I don't know if you can read it, but it says version 1.08 there at the top. So if I want to make a change to my application, and I guess the important part here is that this might be something that you do in an office, you change your code, you push it, but this might be something that is deployed into the field where someone on site has to make changes to your application, optimize whatever is actually running, and then has to then push that on site. So that person would have to be able to push their code, but also validate it immediately as well. In this case, it's just very simple. The application itself that is pulling those resources, that's always there. I change then, just the index.html to just change the version text, basically, not really doing any big changes. However, what it is doing, of course, it's changing my code. So whatever was initially attested, there's a change to it. So I need to re-sign everything. This has been built. I have, of course, if you do this correctly, in the automation itself, it's going to add the new digest for your image. So of course, you'll need to pull, rebase, and then push. In my GitLab, is it GitLab action? My GitLab automation, there's then all of the scripting for doing, for example, the actual creation of the change in the image, the creation of the provenance, the attestation, and then of course changing the digest, pushing the new version, and then pushing that, of course, to the container repository, but also the new configuration for my Kubernetes resources, because now my Docker container digest has changed. That digest also needs to be changed in my Kubernetes resource, or else, Argo CD won't know what then to apply. There's options there, but sure. So that all of that is an automated, applied, pushed to, in this case, Docker Hub. The provenance is attached, signed, and once all of that is done, basically, within the pipeline, you get a new signed image, a new provenance, and then something to then deploy to your environment. Let's move this on a little bit. So a new digest for the image, that's then applied by Customize, so that's all available. Argo CD will then see that change. And then once all of that is recognized, it will try to sync your new configuration. I hope it's revisible there. In this case, just forcing a sync on Argus CD side, or else it might take whatever time you put into that. I think 3 minutes by default. And if I then look at the resources themselves, you'll see that my application is, well, one out of sync, but also it can't deploy, and I don't know if you can read that, but it says, hey, no matching attestation, because I have made a change to my code and I have pushed it. The Kubernetes resources have changed, the Docker image has changed, but there's no signed provenance. There's no provenance attached. So I have a script, I run that script against the Git repository itself, and it then asks me to sign the image. In this case, it does two things. So it first allows me to sign the image itself, and then it creates the actual provenance as well. So what you're not seeing here is, like Nicolas said, this is all hardware backed. So it's asking me to put in my PIN. My YubiKey will start lighting up. I tap the YubiKey, and then of course that will do the first signing, and then it will do the second one. So again, PIN, sign, and then push. This then adds that provenance to the the resource itself, and with that added, Argo CD will be able to then get those resources when it deploys that as well. So if the sync is then forced again, now that everything is signed, attested, and correct, the sync will, it's a video, so it's not going to film. The sync will work, and the new resource will be deployed, basically. But what you're seeing here, while this then deploys, is you have that hardware component. So you make a change, and you need to make sure that whoever changed it does the actual signing of the resources. And then you have your admission control within the Kubernetes cluster, which then allows you to then deploy your new signed resources. And then we'll see the new version of my changed application. With all that was changed was the version itself. But yeah, so this of course is a very, very simple. However, it can be across an entire application landscape. It can be in the cloud, data center, on the edge. It doesn't really matter. But in this case, all this means is you know what's being deployed in the environment is trusted and is signed by, whoever knows what they're doing.
So what did we just see? We didn't change Kubernetes. We didn't add complexity for developers, at least I hope. We added verification at the right place. Every workload, every artifact is now validated before it runs, not based on configuration, not based on trust, but based on cryptographic evidence. And that's the shift we want to leave you with. Because it's easy to steal a token, but it's far more complicated to steal your own YubiKey. You will still have your token, but you will have also a YubiKey with you. YubiKey or any cryptographic hardware. So what does this mean in practice? It means we rely on proof, not promises. We rely on evidence, not configuration. We rely on verification, not trust. This is not just a tool set, it's a shift in mindset. From I trust my pipeline to the artifacts proves it deserves to run. This is the way.
Yeah, so you've seen you've heard the theoretical side, you've seen the recorded side. If you have more questions, we are around. So today with Edge Day and even I think AI Day, we'll be around the corner at least for the pilot booth. So if you have questions about the actual demo itself, please drop by. Nicolas and myself will be there. I have to be there. Nicolas will be around, hopefully. We also have, on your left, you'll see a QR code. So Nicolas and myself have co-authored a blog that's on the Airbus website. So named Why the Software You Trust Might Be the Biggest Threat to Your Infrastructure. So feel free to take a look at that. For KubeCon starting tomorrow, we will be on booth 420. I won't go further into that. And if you have any other questions, you can drop by, and if you have time now, of course, we'll take some questions as well.